بهيدا الفيديو تلاميذنا رح نحاول انه نمرق كذا اوبجكتيف علشان نختصر الوقت، وانتو فيكن تعيدوا الفيديو كذا مرة اذا حسيتوا انه الافكار كتار عليكم. اول شي خلينا نبلش بالsensory receptor. The sensory receptor that is shown here is a structure that is able to convert, to receive the information, the stimulus, يعني as the light, the pressure, the heat, and any other stimulation, vibration, to create a nerve message in the fiber that is connected to it. This message will be transmitted to the center, and this fiber is surely a sensory nerve fiber because it transmits sensory messages toward the center. It is an afferent nerve fiber. The receptor in this case is able to receive the stimulus. In this case, the stimulus is given here. The intensity of the stimulation is given. There are two stimulations, the first and the second, and the intensity of the stimulation is increased in order to observe what can we find as a result in the receptor at the beginning. At the receptor, we observe after the first stimulation, we observe this variation of the potential, and when it is increased, we observe an increase in the amplitude obtained in the receptor potential. This variation in each of the two cases is called receptor potential. The receptor potential is the variation of amplitude is the variation of the potential inside the receptor that can be recorded by the oscilloscope. This variation in the potential and the receptor potential leads to action potentials in the fiber. This is the fiber, this is the oscilloscope, and it records the different action potentials obtained at the end. This simple experiment will make us take many conclusions. The first conclusion is that the intensity of the stimulation is coded by the amplitude of the receptor potential. Since when we increase the intensity of the stimulation, there is an increase in the amplitude. This means that in the receptor, we can know that a stimulation is high or low if we observe the amplitude obtained in the receptor potential. The same stimulus leads to different results at the level of the nerve fiber. This means that the number of action potentials is not the same in both cases, but they are still obtained in the same time. So the number of action potentials per unit of time is different. It is like we obtain here 6 action potentials per second, and here we obtain about 11 action potentials per second, or 9. It is 9 action potentials per second. Here we can say that there is an increase. It is an increase of a number, but because of the number is obtained in the same time, we can say that this is an increase of the frequency of action potentials. هيدا الشيء بيقلنا إنه the intensity of the stimulation that is obtained by increasing the stimulation is coded here by the frequency of action potentials. فإذا لحد هلا نحن صرنا حكيين 3 أشياء. The receptor receives the stimulus and give a difference in the potential inside it called receptor potential that creates the nervous message. This receptor potential increases in amplitude with the increase of the intensity of the stimulation and leads to an increase in the frequency of action potentials in the fiber. So we can say that the intensity of stimulation is coded by amplitude inside the receptor. It is coded by frequency inside the nerve fiber. الاشياء التانية بنلاحظ مثلا انه when we increase the intensity of the stimulation مثل ما شفنا هون, the amplitude of the action potentials remains the same. يعني the action potential doesn't increase in amplitude as a function of the increase of the intensity of the stimulation. هيدا الفكرة اللي بنقلها conservation of the amplitude with the increase of the intensity of the stimulation, وبعد شوي حنسميها بطريقة تانية. هيدي فكرة. الفكرة التانية, we can say that the action potential is obtained here and it is recorded here. And if we record it a third time, it will be recorded here. So the action potential is propagating. The nerve fiber itself is conductible and the nerve message is propagable. And within its propagation, it conserves the amplitude constant. It means that when the action potential is propagating, its amplitude remains the same. This is the second property. A third one, that not all the stimulations can give action potentials. Here, for example, you can observe here, this is that we call the threshold. The threshold of intensity of stimulation. A stimulation that is below the threshold gives no action potentials. But when it exceeds the threshold, it can give you some action potentials. And this is the idea, I will repeat it. With the increase of the intensity of the stimulation, the amplitude remains the same, but the frequency that was 3 here increased to be 6 here. Here, the frequency increases with the increase of the intensity of the stimulation by applying it on a receptor. This is the idea that we repeated it before. In this figure, you can observe that there are many stimulations done without obtaining action potentials. These are below threshold stimulations. The threshold is the least intensity leading to an action potential. It can be this one or a little less than it. And with the increase of the intensity of stimulation, no more increase of the action potential amplitude is obtained. This is what we call, and I said we will say it, law of all or none. All or none means even I obtain a complete action potential or I wouldn't obtain any action potential. Third, for the nerve, what is a nerve? A nerve is a set of nerve fibers. This is a nerve, and these are the nerve fibers that are inside the nerve. When we increase the intensity of the stimulation, as we have here, the first and the second stimulation, no action potentials are obtained because no one of the fibers is excited. At the stimulation called threshold, we obtain a very low amplitude of a potential called global potential. Why we call it global potential in the nerve? Since when we increase the intensity of the stimulation, we obtain an increase in the amplitude of this global potential. Since every time we increase the intensity of stimulation, we will obtain more excited fibers. This is the nerve. These are the fibers. And this is the first action potential that is obtained at this point. At this stimulation intensity, we obtain one action potential. We record it with this amplitude. When we increase the intensity of the stimulation till the second, we obtain not only one, we obtain in two different fibers, two different action potentials. This is the first, and this is the second. As a sum of them, we record a higher amplitude because the oscilloscope that records these global potentials is connected to the nerve from its outside. It is not connected to it by introducing it in every fiber. This is impossible. We connect the oscilloscope at the surface of the nerve. Also, when we increase again the intensity of the stimulation, we obtain higher amplitude since, guess what? How many action potentials do we obtain here? We obtain, per example, 3 action potentials in 3 different fibers. The sum of them is obtained here. That's why we say that the nerve obeys the law of summation. But the fiber doesn't obey this law. The fiber obeys the law of all or none. All or none means that, as we said, it gives you either a complete action potential or no action potential. If we increase more the intensity of the stimulation, we will get higher action potential, higher global potential. As we increase the intensity of stimulation till the end, all the fiber will be excited and they give us this global action potential of maximum amplitude, and it will be obvious that the increase of the intensity of the stimulation will not be able to increase more the amplitude since all the fibers are excited as we said. This will repeat for us many ideas. The first idea is the idea of the threshold. If the intensity of stimulation reaches the threshold, we will be able to obtain action potential or a global potential. Below the threshold, no action potentials are obtained, and as we increase the intensity of the stimulation, the number of excited fibers will increase till we reach the maximal number of excited fibers that are all the fibers in the nerve. So when the intensity of the stimulation increases, we will obtain a stable and constant amplitude of global potential, and we will not be able to increase it more as before. فإذا نرجع بنحكي الأفكار على السريع اللي حكيناهن. ريسبتور بيستقبل الستيميوليشن، بيخلق منها ريسبتور بوتنشال. إذا كانت مثل ما قلنا فوق الثريشولد مش تحت الثريشولد مثل هون. إذا كانت فوق الثريشولد رح نلاقي بقلب الريسبتور بوتنشال عالي فوق الثريشولد، واللي بيؤدي ل many action potentials in the fiber. Whole action potentials will be propagating, will propagate in the fiber, and when they propagate they conserve the amplitude. فينا نسجلهم وين ما بدنا بالفايبر حنلاقي نفس الامبليتيود. و if we increase the intensity of the stimulation we will observe an increase of the receptor potential in the receptor, and we will have an increase of the frequency of action potentials in the fiber. بقلب النيرف ما حلاقي هيدي القاعدة law of all or none اللي شفتها هون، لأنه هون أو أنا عندي no action potentials أو عندي constant action potentials حتى لو زادت الintensity of the stimulation. بقلب الفايبر حلاقي هيك، بالنيرف ما حلاقي أول شيء، بعدين حلاقي action potential، والaction potential will increase its amplitude with the increase of the intensity of the stimulation حتى يصيروا كل الفايبرز excited ويصير هيدا الامبليتيود ثابت ما عادش حيزيد بآخر increase of the intensity of the stimulation. هيدا هو اللي حبينا نشرحه اليوم، وإن شاء الله بالأيام الجاية بنكمل بخصائص الفايبر والنيرف وبعض الأشياء الجديدة.